So hello guys, I'm Mathew Javier and this is a video about chapter 7 tutorial. So now guys, we're going to talk about first IP addressing. So first, welcome to my video. And what is an IP addressing? Addressing is a critical function of a network layer protocols. So it also enables data communication between hosts regardless of whatever the hosts are on the same network or different networks, but both Internet Protocol version 4 IPv4 and Internet version Protocol 6 IPv6. It also provides guys that the hierarchical addressing for packets that carry data. So guys, designing implementing and managing an effective IP address plan ensures that networks can operate effectively and efficiently. So guys, listen carefully. This chapter examines in detail the structure of IP address and their application, construction, and testing IP networks and subnetworks. So guys, we are now in the IPv4 network addresses. We have a binary and decimal conversion, IPv4 address structure, IPv4 unicast, broadcast, and multicast, and types of IPv4 addresses. First, we're going to have a binary and decimal conversion. So, IPv4 address and binary is numbering system that consists of 0 and 1 call bits. In contrast, the decimal numbering system consists of 10 digits consisting of the number 0 to 9. So guys, binary is important. Why? For us to understand, because host, servers, and network device use binary addressing. Specifically, they use binary IPv4 address as shown in those in figure of chapter 7. As I remember, 7.111 is the binary addressing. So guys, that is all about the IPv4 addresses. So the next one is the positional notation. Positional notation. Learning to convert a binary to decimal requires an understanding of positional notation. It means that a digit represents different values depending on the position the digit occupies the sequence of numbers. You already the most common numbering system, the decimal base 10 notation system. So the example that will how you illustrate how binary number in the activities in chapter 7 will tell you more about, or will give you more idea about the positional notation. So there are radix. So radix is the first row identifies the number of radix. The decimal notation system is base 10, therefore the radix is 10. So there are radix, position in number, calculate, and positional value. So there are guys there are also an activity which is called binary game in chapter 7. Hope you play it and you can practice there the binary game to decimal to binary, binary to decimal. The next one is IPv4 address structure. So network and host portions. So understanding binary notation, it is important when determining if two hosts are in the same network. Recall that an IPv4 address is a hierarchical address that is made up of a network portion and a host portion. So guys, when determining the host portion, it is necessary to look at the 32 binary stream. Within the 32-bit stream is a portion of bit identity. The network and a portion of the bits identify the host as shown in the figure. So the bits within the network portion of the address must be identical for all devices that resides in the same network. The bits within the host portion of the address must be unique to identify a specific host within a network. If two have the same bit pattern in the specified network portion of 32-bit stream, those two hosts still reside in the same network. But how do thus know which portion of 32 bits identify the network and which identifies the host? That is the job for the subnet mask. So what guys is the subnet mask? So a subnet mask is IPv4 address mask big configuration IPv4. So it consists of IPv4 address, unique IPv4 address of the host. Subnet mask is used to identify the network host portion, the IPv4 address. Default gateway identifies the local gateway router interface. To identify the network host portion of IPv4 address, the subnet mask is compared to the IPv4 address bit of form. Left to right, as shown always, is going to the first subnet mask identify network while the zeros identity the host portion. Note that the subnet mask does not actually contain the network or host portion of an IPv4 address. It just tells the computer where to look of this portion in the given IPv4 addresses. So the actual process used to identify the network portion and host portion is called ANDing. So there are also IPv4 unicast and broadcast system. So there are IPv4 communication, unicast transmission, multicast. So first is the unicast. Unicast transmission is communication used to normal host to communication in both client-server to peer-to-peer network. Unicast packets use the address of the destination device as the destination address and can be routed through a internetwork. So note that in this course, all communication between devices is unicast unless otherwise is noted. So IPv4 unicast host address are in the address of the range of all zeros to 223, 255, 255. However, within this range of many addresses, there are reserved for special purpose. These are purpose address will be discussed later in the chapter 7. Next one is the broadcast transmission. Broadcast transmission. Broadcast traffic used to send packets to all the networking using a broadcast address for the network with a broadcast packet contains a destination IPv4 address with all ones in the host portion. This means a lot of the hosts that local network broadcast domain will receive and look at the packet. Many network protocols such as DHCP use broadcast when a host receives a packet from the network broadcast address to host process the packet as it would packet address to the unicast address. So that is the broadcast transmission. So, next one is the multicast transmission. Multicast transmission is a transmission that reduces traffic by allowing hosts to send a single packet to a selected set of hosts by multi-group. Next one is the type of IPv4 address. type of IPv4 address have a public and private IPv4 address, activity, pass or block, special user IPv4 address, legacy, class, full address, and classful IPv4 addressing, classless addressing, assignment of IP address, etc. and so on and so forth. So the next one is going to tackle about is IPv6 network access. So the issues of IPv4 and IPv6 address and IPv6 addressing, types of IPv6 address, unicast address and multicast address. So first, the need for IPv6. The need of IPv6 is designed to successor to IPv4, IPv6, a larger bit address providing 340 and decillion address, that is number 340 followed by 36 zeros. However, IPv6 is more than just a larger number. When the IETF began its deployment of successor to IPv4, it is used to opportunity to one of example Internet Control Message Protocol version 6 ICMPv6, which includes the address resolution, address auto configuration not found in ICMP for communication, and ICMPv6 will be discussed later in this chapter. So the need is the depletion of IPv4 address space, the motivating factor of moving IPv6 as Africa, Asia, other areas of the world become more connected to the internet. There are now enough IPv4 address to accommodate the growth as shown in the figure. So IPv4 address. So that is the IPv4 need, or the need of for IPv6. So the next one is IPv4 and IPv6 coexistence, and the next one is IPv6 addressing. IPv6 address are 128 bits in length and written as a string of hexadecimal values. Every 4 bits is represented by a single hexadecimal digit for a 32 hexadecimal values as shown in the figure 1. IPv6 addresses are not case sensitive and can be written in the either lowercase or uppercase. So that is IPv6. The next one is the type of IPv6 address. IPv6 address types. There are 3 types of IPv6 address. First is the unicast. An IPv6 unicast address uniquely identifies interface on IPv6 enabled device as shown in the figure. A source IPv6 must be a unicast address. Second one is a multi-key address. An IPv6 multi-key address is used to send a single IPv6 packet to multiple destinations. And the third one is anycast. An IPv6 anycast address is any IPv6 unicast address that can be assigned to multiple devices. A packet sent to an anycast address is routed to the newest device having that address. Anycast addresses are beyond of the scope of this course. So the next one we're going to tackle about is IPv6 network addresses. So IPv6 network addresses and the connectivity verification. So connectivity verification is that it has ICMP and testing verification. So ICMP v4 and ICMP v6. So ICMP v4 and IPv6 is, although IP is the best effort control, TCP/IP does not provide for message to be sent in event certain errors. Purpose of this message is to provide feedback about issues related to an processing IP conditions, not make a reliable ICMP and that are often not allowed within a network security reasons. So the next one is the ICMP router solicitation router advertisement messages. The information and error messages found in ICMP-v6 are very similar to control and error message implemented by ICMP4. However, ICMP has new features about improved functionality not found in ICMP-v4, and ICMP-v6 messages are encapsulated in IPv6. So ICMP-v6 include the four new protocols as part of their neighbor discovery protocol. So first is messaging between IPv6 router and IPv6 device. Router solicitation RS message or router advertisement RA message. Messaging between IPv6 devices, neighbors solicitation NS or neighbor advertisement NA. So the next one is testing and verification. There are ping to testing the local stack, ping testing connectivity to the local LAN, and ping testing connectivity remote, trace route or tracing path. So that is all about connectivity and verification. So I hope, and that is all, and thank you for watching this video, and I hope you learned something from the chapter 7 IP addressing. And again, I am Mathew, and that's all, and thank you.